Good morning, student. Today, the 12th chemistry class. Previous class, that is a lesson name is what? Solution lesson. That is a lesson name is solution lesson. Previous class, we are discussing about Henry law. That is so far we are discussing about gas dissolved in liquid. Gas dissolved in liquid. Gas dissolved in liquid. That is a Henry law. So far we are discussing about gas dissolved in liquids and Henry law. Today class is solubility of solid in liquid. Solubility of solid in liquid. That is solid dissolved in liquid. That means that is a liquid. If you consider this water molecule, you add sodium chloride. This is a solid. Solid dissolved in water. That is a solubility of solid in liquid. Today we will be discussing about this. Learn about solubility of solid in liquid. Okay. First solubility. Solubility of solid in liquids. That is a sodium chloride or potassium chloride or sodium carbonate, potassium carbonate or sodium sulfate, and solubility of solid in liquids depend on what is the depending nature of the solid and liquid. The solid nature. The solid nature may be ionic or covalent compound. That is a polar molecules, polar solute or non-polar solute. And solvent, polar solvent or non-polar solvent. That is a depend on nature of the solid and liquid. The first nature of the solid and liquid. Second factor is a temperature. Second factor is a temperature. If it is when is temperature increasing, solubility increasing or decreasing. So temperature decreasing, solubility increasing or decreasing. Third factor is a pressure. That is a three factor affecting the solubility of solids in liquid. That is depending on solubility of solid in liquids depend on three factor. One is a nature of the solid and liquid. Nature of the solid. That is a solute is a solid. Solute is a solid. Liquid is a solvent. Liquid is a solvent. Second, temperature factor. Second is a temperature factor. Third is a pressure factor. Third is a pressure factor. So these three factors now we will discuss about solubility of solid and liquid. First, nature of the solid and liquid. That is the nature of the solid and solvent nature. Previous class we learned about like dissolved like. That is polar molecule only dissolved in polar solvent. Polar solute only dissolved in non-polar solvent. Non-polar solute only dissolved in non-polar solvent. That is like dissolves in like. Like dissolves in like. Say in this box you consider this. Polar solute only dissolved in polar solvent. That is like dissolved in like. Polar solute only dissolved in polar solvent. Non-polar solute only dissolved in non-polar solvent. Non-polar solute only dissolved in non-polar solvent. That is a like non-polar. Like dissolved in like. Like dissolved in like. Like dissolved in like. That is a polar solute only dissolved in polar solvent. Non-polar solute only dissolved in non-polar solvent. Non-polar solvent. Okay. Now, so one example is there. First, the first one, polar solute. Example: sodium chloride, potassium chloride, potassium iodide. This is a polar solute. That is a polar solute. Sodium chloride, potassium chloride, and potassium iodide. This is a polar solute. That is means in this solute dissolve in water to form ions. Sodium chloride, when it dissolve in water, is known as ion formation. KCl dissolve in water, ions formation. And Ki dissolve in water to form ions. So this is a polar solute. This is known as polar solute. Sodium chloride, potassium chloride, and potassium iodide is a polar solute. Only dissolve in polar solvent. Water is a polar solvent. Water is a polar solvent. Water is a polar solvent. Next, so this is a polar solute. Polar solute. Sodium chloride, potassium chloride, and potassium iodide dissolved in polar solvent. Next example, naphthalene and anthracene. Naphthalene and anthracene is a non-polar solute. Non-polar solute. Naphthalene and anthracene is a non-polar solute dissolving benzene and carbon tetrachloride. It is a non-polar solvent. So, non-polar solute, naphthalene and anthracene only dissolve in non-polar solvent. There is a benzene and a carbon tetrachloride. Benzene and a carbon tetrachloride. Okay. Now, this sodium chloride and potassium chloride and potassium ion does not dissolve in benzene and carbon tetrachloride because this is a polar solute cannot dissolve in non-polar solvent. Like, not like. This is a dislike. So only polar solute only dissolve in polar solvent. This polar solute not dissolve in non-polar solvent. Then another non-polar solute, that is a naphthalene and anthracene. Naphthalene and anthracene cannot dissolve in water because water is a polar solvent. Naphthalene and anthracene is a non-polar solute, cannot dissolve. Okay, this is a like dissolve like dissolve like. Now, okay, now you consider this. You take one beaker. You take one beaker. You fill it with water. This is a water. This is a water. Now you add sodium chloride. Sodium chloride is a solute. This is a solvent. Water is a solvent. Sodium chloride is a solute. Water is a solvent. Sodium chloride is a solution. What happens when sodium chloride dissolves in water? That is sodium chloride when dissolved in water, it forms sodium ion and chloride ion. Sodium ion and chloride ion. What happens when ionic compound dissolved in water? It forms sodium ion and chloride ion. This process is known as dissolution. This process is known as dissolution. This process is known as dissolution. Okay? When solid dissolve in water, dissolution process is known as endothermic process. Dissolution of salt in water is known as endothermic process. This is an endothermic process. When sodium chloride dissolve in water is known as endothermic. But a gas dissolve in water. But gas is the water. You dissolve sulfur dioxide or trioxide. Sulfur trioxide. This is the dissolution of sugar, dissolution of gas. This is known as exothermic process. When gas, this is solid, is known as endothermic. When solid dissolved in water is endothermic, gas dissolved in water is known as exothermic. Okay, this is a dissolution of process is endothermic. Okay, now you continuously add, that is known as dissolution. The process of dissolving sodium chloride in water is known as dissolution. Dissolving sodium chloride salt in water is known as dissolution. This is known as dissolution. Dissolution of sodium chloride. Dissolution of sodium chloride. Now you add continuously sodium chloride. Add by add. So what happens is attain saturated solution. Maximum amount of solute. That is a saturated solution. Then extra you add sodium chloride. The solution attains saturated solution. Then extra you add sodium chloride added. What happens? This sodium chloride and sodium ion and chloride ion is a collision which takes place and it forms crystallization process. That is a crystallization formation. Okay, this is a one. First dissolution, when sodium chloride is added, the solution is attained saturated solution. Then you add extra solution, extra solute is added to the at saturated solution, crystallization takes place. There is a crystallization takes place. This is known as crystallization at particular temperature. Particular temperature. Dissolution and crystallization and it takes place. Now, this is next solution, solid solution. These are two categories, three categories. We already discussed about solid liquid. That is three category. One is unsaturated solution. Unsaturated solution. Second one, saturated solution. Third one, supersaturated solution. Supersaturated solution. Okay, now you consider this examples, saturated and you take a beaker, you fill it with water, then trace little amount of sodium chloride is added. That is a more solute dissolved. More solute dissolved. This is known as unsaturated solution. Unsaturated solution. Now, saturated solution, the same. You add sodium chloride, continuously is added solute sodium chloride. Continuously you add sodium chloride on particular condition, particular state, no more solute is dissolved. No more solute dissolved. No more solute dissolved. That state is known as saturated solution. That state is known as saturated solution. Saturated solution. Now, supersaturated solution, same beaker will take water, filled with water. You add continuously sodium chloride. First it become a unsaturated, then it become a saturated solution. Then you add extra sodium chloride, that is a supersaturated solution. In supersaturated solution, crystallization takes place, that is a precipitation. Precipitation form. That is a supersaturated solution. Supersaturated solution. So this is a unsaturated solution, then saturated solution, then supersaturated solution. Unsaturated, more solute dissolved. More solute dissolved. Saturated solution, no more solute dissolved. Particular stage you attain, no more salt dissolved. That is a saturated solution. Supersaturated solution, you are first attain the saturated solution, then extra you add sodium chloride. This sodium chloride is a crystallization formation. That is known as supersaturated solution. That is a supersaturated solution. So, solid dissolved in liquid, three factors. One is a nature of solute and solvent factor. Second, that is a nature of solute and solvent factor. Second factor, that is a temperature. Second factor is a temperature. Second factor, temperature. Okay, second factor, temperature. That is a solid dissolved in liquid. You know, dissolution of solid. Dissolution of salt. That is endothermic process. Maximum endothermic process. That is a temperature increasing, solubility increasing. Endothermic process, that is means solute plus solvent plus temperature, that is a heat. As per Lee-Chatelet principle, we already studied in the 11th standard. Solute, that is a solid. Solute, what is the nature? Solid. Solvent plus heat. Now, this is the endothermic process, that is the equilibrium. Solution. This is the endothermic. When temperature increasing, dissolving nature increasing. This is known as dissolution of salt. Dissolution of salt in liquid. This endothermic. So, temperature increasing, solubility increasing. But in gas state is a dissolution of gas or solubility of gas in liquid. Gas in liquid is exothermic. Solubility of gas in liquid is known as exothermic process. Exothermic. So entirely different. Okay. This is also different. Is that okay? One example, you consider this. You take a one beaker. That is a water. You fill it with water. Filled with water. You add sodium chloride, salt. Sodium chloride. This continuously add. First unsaturated condition. Then attain saturated condition. Then attain saturated conditions. Unsaturated condition, no more solute dissolve. Sir, more solute dissolve. More solute dissolve. But saturated, no more solute dissolve. Okay. First unsaturated condition attained. Then you will add extra sodium chloride, is attained saturated condition. In this saturated conditions, no more solute is dissolved. Okay? Then what happened? Now, in this condition, now you heat it by using the Bunsen burner. Bunsen burner, you heat it. What happened? Now temperature increasing, then you add extra NaCl. Then you dissolve. So in this condition, temperature increasing, what happened? This solution saturated is converted into unsaturated. Saturated condition is converted into unsaturated. And at this condition, more solute NaCl added. This is known as temperature increasing, solubility of solute is increasing. Solubility of solute is increasing. But exception case is there. Exception case is there. What exception case? What is the exception cases? 3 cases is there. First case, solubility increases when temperature increases. That is temperature increase, then solubility increasing. Temperature increasing, solubility increasing. That example, sodium chloride, potassium chloride, potassium iodide. These 3 salts, when temperature increasing, solubility increasing. Temperature increasing, solubility increasing. Which salt? Sodium chloride, potassium iodide. But temperature increasing, solubility decrease. Solubility decrease when temperature increasing. That is temperature increasing, solubility decreasing. Temperature increasing, solubility decreasing. Say example, calcium carbonate, that is temperature increasing, solubility decreasing. Example, calcium sulfate and lithium sulfate. These two salt, when temperature increasing, solubility decreasing. That is a calcium carbonate and lithium sulfate. This is the exception cases. Third case, solubility increases particular temperature. Solubility increases up to a certain temperature, and then decreases. With increasing temperature. And then decreases with increasing temperature. Increasing temperature. Example, sodium sulfate. Sodium sulfate is a maximum solubility 32.8. That is, you see, one graph is there. This is a solubility. Y-axis solubility, x-axis temperature. Now, you sodium sulfate salt. First lowest temperature. Now temperature increasing. One particular temperature, solubility highest. That temperature is 32.8 degrees. Then decreasing. This is known as this temperature is known as transition temperature. In this transition temperature, solubility decreasing. When reaching the transition temperature, then further heating, the solubility of salt is decreasing. This temperature is known as transition temperature. 32.8 degree for sodium sulfate. When sodium sulfate increasing, solubility increasing, first temperature increasing. Room temperature is 25 degree. Then you heat it, continuously dissolving. Particular temperature, that is 32.8 degree, is reaching, solubility will decreasing. So this is the three categories when temperature. First, generally dissolution of salt is exothermic. Dissolution of salt is exothermic. Temperature increasing, the solubility increasing. But some exception cases is there. First case, salt increasing, temperature when temperature is increasing. Example, sodium chloride, potassium chloride and potassium iodide. Temperature increasing, solubility continuously increasing. So first unsaturated condition, then saturated condition, then supersaturated condition will obtain. Second is solubility decrease when temperature increases. This is opposite. Temperature increasing, solubility decreasing. Say example, calcium carbonate, lithium sulfate salt. When temperature increasing, solubility decreasing. Now solubility increase first and then decrease. That is for particular temperature reaching, then decreasing. That temperature is known as transition temperature. Example, say example sodium sulfate, and temperature is 32.8 degrees centigrade. That's all. Now, third factor, pressure. So, first factor, nature of the solute and the solvent. Second factor, temperature. Third factor, pressure. So first factor, what is solubility of solid in liquid is affected by first factor, nature of solute and liquid, that is a solvent. That is polar solvent, polar solute only dissolve in polar solvent. Polar solvent. Non-polar solute only dissolve in non-polar solvent. This is the nature of the solute and liquid. First factors. Second factor, temperature. Second factor, temperature. Temperature means when temperature, dissolution of salt is exothermic. Dissolution of, first you will learn dissolution of salt, endothermic. But gas is exothermic. Dissolving gases in liquid is exothermic. This is endothermic. So temperature increasing, solubility increasing. Say example, NaCl, KCl, potassium iodide. This salt when temperature increasing, solubility increasing. This salt temperature increasing and solubility increasing. Second, temperature increasing, solubility decreasing. Temperature increasing, solubility decreasing. Example, lithium sulfate, calcium carbonate. Lithium sulfate, calcium carbonate. Third, first temperature increasing, solubility increase. Then temperature increasing, solubility decrease. Say example, sodium sulfate. Say example, sodium sulfate, that is 32.8 degrees centigrade. This is the transition temperature, TC, transition temperature. First increasing, then this is the three factors. Three exception cases, two exception cases. Then third factor, pressure. Pressure. First, nature of the solute and liquid. Second, temperature. Third, pressure. Pressure does not affect solubility of solid in liquid. Pressure not affect. Pressure does not affect solubility of solid in liquid. Solid in liquid. Solubility of solid in liquid. This is a solubility of solid in liquid. Okay, that's this topic over. Next, vapor pressure of liquid solution. Next topic, vapor pressure of liquid solution. vapor pressure of liquid solution. Okay, liquid solution is vapor pressure. Okay, first you take a one beaker, that is a closed vessel. Take a beaker. Then you filled with volatile liquid. That is a closed vessels. That is a closed vessels. You filled with volatile liquids. This is a volatile liquid. This is a volatile liquid. What happens when it's open in here? It's kept in open. That is a closed vessels. What happens when temperature? That is a sunlight. That is a temperature. What happens? This liquid. That is a surface side liquids. Is observing temperature from the surrounding. So this kinetic energy is increasing. Kinetic energy on the surface liquid is increasing, then is evaporated. That is this is a vapor of this liquid. Vapor of liquid. Maximum pure liquids, that vapor is escaping. This is a vapor pressure of liquid. Vapor pressure of this liquid. Vapor pressure of liquid. Vapor pressure of liquid. That is escaping from the surface area. This is a surface area, liquid surface area is escaping. That is a vapor pressure. Okay. Now, what is the topic? This is a pure liquid. But what is the topic? Liquid solution. Solution means one solute compulsory present, one solvent. Here only solvent I have. This is a solvent. Solvent means example water molecule or ethanol or any take a solvent. Okay. But topic, what's the topic? Liquid solution. Liquid solution means compulsory one solute plus one solvent is present. Maybe the solute solid or gas or liquid, but we were discussing about only solid. Okay. Now the same conditions. Take beaker, liquid solution. Liquid solutions. This is a pure solvent. This is a pure solvent. Pure solvent. This is a solute plus pure solvent, one solvent. The solute is a solid, particularly non-volatile solvent. Non-volatile solute. Non-volatile. That is not evaporated solvent. That is a sodium chloride. This is not evaporated. This is a volatile, means evaporation. Evaporation takes place. This is a non-volatile solute. Okay. In this liquid solution, that solute is compulsory non-volatile. One non-volatile plus solvent is a volatile. Solvent is a volatile. That is evaporation takes place. Volatile means evaporate. Non-volatile, no evaporation. No evaporation. Okay. Now you consider this. The same beaker or any vessels. You take, you fill with water. Water is a volatile solvent, evaporated solvent. Closed vessels. Okay. Then you add sodium chloride. You add sodium chloride. You add sodium chloride. You add sodium chloride. So in a surface area is sodium chloride. This is a solvent. So in a surface area, Here also solute, non-volatile solute is present. Here surface area only solvent only present. Only solvent only present. Pure solvent only solvent. But here solution, solvent plus solute is a present. Solvent plus solute is a present. Here number of solvent molecule is less. Solvent less. At surface. At surface, number of solvent 1, 2, 3, 4, 5, 6, 7. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So maximum solvent. Here minimum solvent molecule. Minimum solvent molecules. Minimum solvent molecule. Then we continue one half a day or 2 hours or 3 hours. What happened? The solvent is a volatile. Solvent is a volatile. Solute is a non-volatile. What happened? This solvent is evaporated. Only solvent only evaporated, but number of molecules is less. Comparing pure solvent, so vapor pressure is decreasing. Comparing pure solvent. Comparing pure solvent. Comparing pure solvent. Pure solvent. That is a liquid solution. One solute is a non-volatile, one solvent is a pure volatile. Pure solvent is a volatile. The vapor pressure is decreasing. Vapor pressure decreasing. That is a non-volatile solute dissolved in liquid. The vapor pressure of pure solvent is a decreasing. Vapor pressure of pure solvent is a decreasing. Vapor pressure of pure solvent decreasing. Then vapor pressure solution contain volatile solvent in non-volatile solute. This is a now, next topic is a Raoult law. You know, previous class we are learning about Henry law. This is a Raoult law. Raoult law. Raoult law. You know, previous class we are learning about Henry law. Henry law only dealing with gas dissolved in solvent. Gas dissolved in liquid. Henry law. But here solid dissolved in solvent. Solid dissolved in solvent. Liquid solvent. That is the Raoult law. So Henry law dealing with what? Gas dissolved in liquid. Raoult law, solid dissolved in liquid. That is the difference. So we will discuss previous class we are learning about Henry law. This Raoult law now we will discuss about Raoult law. Okay. First I will write law, Raoult law. Very simple law. At a given temperature, the vapor pressure of solution containing non-volatile solute. Dealing with the non-volatile solute is directly proportional to mole fraction of the directly proportional to mole fraction of the solvent. Very simple. You take a one beaker, the same, you fill it with volatile solvent water, we add sodium chloride, that is a non-volatile solute. Non-volatile solute. You add the number of solvent molecule is reduced. Number of solvent molecule reduced at the surface. At the surface, this is a solvent molecule. Okay, what happened? Is evaporated. Only solvent is evaporated. Solvent. Now you see, at a given temperature, the vapor pressure of the solution, vapor pressure, not this vapor pressure. This vapor pressure. The gas solvent is evaporated. That is the vapor pressure. Solution containing non-volatile solute. What is the solute? Non-volatile sodium chloride. It's not evaporated solute. That this vapor pressure directly proportional to the mole fraction of the solvent. Solvent mole fraction. Directly proportional to the solvent mole fraction. That is vapor pressure of the solution directly proportional to the mole fraction of the solvent. Mole fraction, solvent here A, solute B, solvent A, or B. Mole fraction of solvent, mole fraction of solvent. Directly proportional. Okay? That is vapor pressure of solution. The directly proportional, proportionally constant, you are using equation form, that is P0. Mole fraction of solvent. This is the pure solvent. P0 is equal to vapor pressure of pure solvent. Vapor pressure of pure solvent. Vapor pressure of pure solvent. This is a guide. That is a mole fraction. How to write? Don't write X. This is a guide. Mole fraction of solvent. Mole fraction of solvent. Then P. Vapor pressure of solution. Vapor pressure of solution. This is the vapor pressure. P. This vapor pressure directly proportional to the mole fraction of the solvent. Mole fraction of solvent. This P0. P0 is a pure solvent. That is what is the meaning pure zero. Na? This is water. Water, no solute. Only pure solvent. This can be open here. This pure solvent molecule evaporating to form this vapor pressure. This is a pure solvent vapor pressure. Pure solvent vapor pressure. In absence of solute, vapor pressure is a pure solvent. In presence of solute, vapor pressure of solution is a directly proportional to the mole fraction of this solvent. Mole fraction of solvent. Mole fraction of solvent. This law is the Raoult law. Okay. Now, Raoult law I will explain in the form of graph. Raoult law explained in the form of graph. This is vapor pressure. Y-axis vapor pressure. X-axis mole fraction. Solvent. That is a 0. Here mole fraction 1. Mole fraction 1. Solvent. Solvent. Yeah, mole fraction 0. no solid, and mole fraction is increasing. Okay, now this is a maximum solvent. This is a solvent. This is a vapor pressure of pure solvent. Vapor pressure of pure solvent. Pure solvent. This is a vapor pressure of pure solvent. When solvent zero, no vapor pressure. When solvent mole fraction increasing, maximum is a vapor pressure. Maximum vapor pressure. Okay. Now, vapor pressure of volatile liquid. Previously we learned about vapor pressure of volatile liquids. That is factors affecting vapor pressure of volatile liquid. Volatile liquid. Now you see, first factor temperature. First temperature. Now you see, take a beaker filled with solvent. This is volatile solvent. Now temperature increasing. What happened? The solvent molecule now heating. In this heat absorbing by the solvent molecule. Heating absorbing by the solvent molecule. The solvent molecule kinetic energy is increasing. Kinetic energy increasing. Kinetic energy is increasing. What happens? The solvent molecule is escaping from the surface. So more vapor pressure is formed. So temperature increasing, vapor pressure of the liquid increasing. Vapor pressure of liquid increasing. First factor, when temperature increasing, what happens? Solvent most evaporated, that is vapor pressure increasing. Second is surface area. Second is nature of the liquid. Nature of the liquid means solvent. Nature of the solvent. Volatile solvent easily evaporated, maximum vapor pressure. That is volatile solvent. Maximum vapor pressure. High vapor pressure. High vapor pressure. When non-volatile solvent, say example benzene and carbon tetrachloride, vapor minimum vapor pressure. Minimum vapor pressure. Minimum vapor pressure. Minimum vapor pressure. This is the second point. Second factor. Third factor, surface area. More surface area, easily solvent molecule is escaping from the system. So more vapor pressure of the liquid. More vapor pressure. These three factors, mainly these two factors, the third factor also affect the factor affecting vapor pressure of volatile liquid. Okay. Now Raoult law. So Raoult law is a dealing with the solid solution, that is a solid solute dissolved in water or solvent, vapor pressure will be directly, solution will be vapor pressure directly proportional to the mole fraction of the solvent. Mole fraction of the solvent. Now, then next, Raoult law is a special case of Henry law. Raoult law is a special case of Henry law. Next topic here. Raoult law is a special case of Henry law. That is the relation between Raoult law and Henry law. Henry law only dealing with gas dissolved in liquid. But Raoult law, solid dissolved in liquid. Solid liquid. No, Henry law. What is Henry law? Henry law. Pressure of the solution direct equal to Henry constant and mole fraction of the solution. Mole fraction. This is a Henry law. Henry law. Henry law. Pressure is equal to mole fraction. Pressure directly proportional to the mole fraction. Here kH is equal to Henry constant. Previous class in that. Raoult law. Vapor pressure of the solvent solution equal to mole fraction. Pure solvent vapor pressure and mole fraction of the solvent. Mole fraction of the solvent. So now you see what is the topic? Raoult law is a special case of Henry law. When KHP equal, it is obeying, Henry law is obeying Raoult law. So equal, therefore it is following Henry law is okay. Okay, today topic is over. Next class we will discuss about ideal solution and non-ideal solution and Raoult law for solution containing. Raoult law is applicable to the volatile component. Next class, so far Henry law, Raoult law we will be discussing. Next class, volatile component Raoult law and ideal and non-ideal solution and colligative property. Only 3 topic is there. That is Raoult law containing volatile component. Second, ideal and non-ideal solution. Third one is colligative property. We will discuss next class. We will learn about next class. Thank you.